Hello and welcome to NPTEL classes. Today I am here to solve chemistry class 12th NCERT problem 2.32 from unit 2nd, that is solutions. Let me read the problem. Calculate the depression in freezing point of water when 10 gram of 2-chlorobutanoic acid is added to 250 gram of water. Given acid dissociation constant of 2-chlorobutanoic acid is 1.4 into 10 raised to power minus 3 and molar freezing point constant of water is 1.86 Kelvin kg per mole. After reading the problem, I got to know that this problem is based on concept of depression in freezing point. Here 10 grams of 2-chlorobutanoic acid is added to 250 gram of water, and addition of this 10 gram of 2-chlorobutanoic acid to 250 gram of water lowers the freezing point of water, and that decrease in freezing point of water is termed as depression in freezing point. Now we have to calculate that, or I may say like this: after addition of 10 gram of 2-chlorobutanoic acid is carried to 250 gram of water, solution now has lower freezing point than pure water. We now need to calculate freezing point of solution. First we need to calculate difference in freezing point of pure water and solution, and then we can determine the freezing point of solution, which will be lower than freezing point of pure water. Given is acid dissociation constant of 2-chlorobutanoic acid and molar freezing point constant of water 1.86. Solute is 2-chlorobutanoic acid. 2-chlorobutanoic acid. I may write it like this. There are 4 carbon atoms total. But indicates total number of carbon atoms are 4. This will be carbon number 1. Carboxylic carbon will be carbon number 1. To this carbon is attached chlorine, and now here will be 1 hydrogen, here will be 2 hydrogens, here will be 3 hydrogens. This is 2-chlorobutanoic acid. Now 2-chlorobutanoic acid is added to water, and in water it acts as electrolyte. So for us solute is electrolyte, and for solution of electrolyte, depression in freezing point is determined by formula or equation delta TF is equal to I into KF into M. This is expression or equation for depression in freezing point of solution containing non-volatile solute. Delta TF is equal to I into KF into M. Now I need to calculate depression in freezing point. For that I need to determine I, KF is given, and I need to determine molality. So 2 parameters I need to calculate in this equation so as to find depression in freezing point. First, molality. I need to determine first molality. This will be first part of solution of this problem. In second part I will determine value of I, and in last part I can then determine value of depression in freezing point. First I will go for calculation of molality. Molality is equal to, expression of molality is W2 dissolved mass of solute multiplied by 1000 divided by molar mass of solute multiplied by volume, weight of solvent in grams, weight of solvent in grams. This is expression for molality of solution. Now weight of 2-chlorobutanoic acid is given 10, W2 is 10 gram. It is added to 250 gram of water, W1 is also given, and molar mass, molecular mass of 2-chlorobutanoic acid is 122.5. So on RHS side all the parameters are known to me. I can determination of molality, calculation of molality is easy. Simple substitution and mathematical calculation. 10 gram of 2-chlorobutanoic acid is dissolved in 250 gram of water, and its molar mass is 122.5. Using this equation I will be able to determine the molality, and I have already done the calculations. Molality comes equal to 0.3264 mole per kg. So step first I completed, in which I determined molality, and molality I got equal to 0.3264. Now I will go for determination of I value, which is my second step. Now remember that 2-chlorobutanoic acid is electrolyte and it is weak electrolyte. 2-chlorobutanoic acid is weak electrolyte. 2-chlorobutanoic acid having this structural formula is weak electrolyte. It is not completely ionized in solution. If I may write its ionization process, I will write CH3, CH2, CHCl, COOH. It will ionize like this. It will not undergo complete ionization. It will undergo partial ionization to give this acetate part. I may write acetate part like this, or I may write like this. 1, 2, 3, 4. B, because there are 4 carbons, I will write but, COO negative, but, C, or I may write like this, but raised power -1 plus H positive. This but raised power -1 will be CH3, CH2, CHCl, C double bond O, O negative. In order to save space here, I wrote but raised power minus 1. 1 mole of 2-chlorobutanoic acid in water undergoes partial ionization resulting in formation of 2-chlorobutanoate ion and H positive ion. And for electrolyte there is a relation that relates Vant Hoffs factor I with degree of dissociation, and that equation is alpha is equal I minus 1 divided by n minus 1. Now n is number of particles which are formed after dissociation of one particle of electrolyte, and from this stoichiometric reaction it is clear that number of particles formed after dissociation of one particle of 2-chlorobutanoic acid are 2. So I may substitute here value of n equal to 2 and alpha will be equal to I minus 1 divided by 2 minus 1. Alpha will be equal to I minus 1. I will be equal to alpha plus 1. Now here I need to calculate alpha, degree of dissociation. In order to find I, which is my second step of solution, I need to find alpha, and for determination, because it is weak electrolyte, weak acid, it will follow Oester's dilution law, and as per Oester's dilution law, alpha is equal to under root of K, acid dissociation constant, divided by C, where C is concentration. Now alpha will be equal to under root of acid dissociation constant is given in the question 1.4 into 10 raised power minus 3. Concentration I need to express in terms of molality, which I calculated equal to 0.3264, and after evaluation degree of, I have already done my calculations here, and after calculating value of degree of dissociation comes equal to 0.0632. This is value of degree of dissociation after calculating this RHS side, in which I need to first divide 1.4 into 10 raised power minus 3 by 0.3264, then evaluate its square root, and it comes equal to 0.0632. So degree of dissociation is 0.0632, less than 1, again affirming that it is not strong electrolyte, it is weak electrolyte. Part of it will undergo ionization, part will remain unionized, and at certain stage there will be equilibrium between ionized and unionized stage, and from that equilibrium we actually derive this relation between its degree of dissociation and Vant Hoffs factor, that for this electrolyte Vant Hoffs factor is degree of dissociation plus 1. Now I will substitute this value of alpha here in order to find Vant Hoffs factor I. I will be equal to alpha, which is 0.0632 plus 1, and it comes I equal to 1.0632. This is value of Vant Hoffs factor for 2-chlorobutanoic acid. Now I will go for see, look here, in first step I needed to calculate molality. I calculated that equal to 0.3. 264. Look again, in second step I needed to calculate value of Vant Hoffs factor for this electrolyte, and that too I calculated equal to 1.0632. Now last step is for the solution of this problem. Last homework or last task required is this. I need to use this basic or fundamental equation of depression in freezing point delta TF and express it in terms of I, Kf and F M. I will substitute simply the value. I is equal to 1.0632 multiplied by Kf is given for water 1.86, and molality also I calculated equal to 0.33264, and value of, I have already done my calculations in order to save time, and value of depression in freezing point comes, depression in freezing point is equal to what? It is equal to freezing point of pure water minus freezing point of solution, and it comes equal to 0.645 Kelvin. Now look again here, on Kelvin scale difference in freezing point of pure solvent and solution is 0.645 Kelvin. On Celsius scale it will again be equal to 0.645, but not in Kelvin, in degree Celsius. So I may write, if I need to calculate freezing point of solution, I will write delta TF, depression in freezing point, is equal to 0.645 is equal to, in degree Celsius I will substitute value T naught, small t naught minus small t. By capital T I represent temperature in Kelvin, freezing point in Kelvin, and small t represents freezing point in degree Celsius. We know freezing point of pure water is 0 degrees Celsius. So freezing point of solution containing 10 gram of 1 chlorobutanoic acid in 250 gram of water will be equal to minus 0.645 degrees Celsius. We all know, whosoever is watching, we all know, this is our daily life experience, that pure water freezes at 0 degrees Celsius. Water starts to freeze at 0 degrees Celsius. But when we add 10 grams of 1 chlorobutanoic acid to 250 gram of water, then solution after addition of 1 chlorobutanoic acid to 250 gram of water, solution won't now freeze at 0 degrees Celsius. Its freezing point, it has undergone depression in freezing point, so solution will now freeze at temperature lower than 0 degrees Celsius, and that temperature in degrees Celsius is minus 0.645 degrees Celsius. Freezing point of pure water is 0 degrees Celsius, and freezing point of this solution will be lower than 0, which is equal to minus 0.645 degrees Celsius. I can also express this freezing point of solution in Kelvin. I simply need to add 273 to this value. Class 12 students, this is the problem which I have got for you today. We are approaching towards the end of exercise of unit 2, that is solutions. See you day after tomorrow with one new chemistry problem. Till then, take good care of yourself, and tomorrow is turn of class 11 students. Allah Hafiz.